Hello, guys. How is it all going? Wonderful. Hey, 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 guys. Welcome to Learn Science with Mital today. I hope you're all well and had a wonderful half term last week. I'd love to find out how your half term went. Oh, and there's my clock. It's 10 o'clock on the dot. You're going to hear it go off at 10:30 as well. So there we go. It's 10 o'clock. Let me know how your half term went. I forgot about my clock. I've moved to a different room today to actually do our lessons. So, okay, well, welcome in the comments. Yeah, just write down what you got up to last week. What was your favorite part of last week? I would love to know. We're getting some more people now on. Lovely. Welcome, welcome, welcome. Okie dokes. Well, last week was great for myself, really. What we did was we held an event called the Vision to Action Growth Club. And last week's theme that we did, which is usually for members only, but I did invite people along as well that were non-members, was to talk about how to develop this burning desire to achieve what you want in life and how to visualize exactly what you want in life. Honestly speaking, I love teaching those lessons because you get to understand so much about your students and understand so much about what their dreams and what their passions are as well. So, if you're new to this, guys, hello, welcome. My name's Mital. I'm the founder and CEO of Spark Academy and also a chemistry teacher. Okay, and we run online tuition as well as center-based tuition as well. And actually, today, unfortunately, is going to be our last ever Learn Science with Mital videos. Okay, so today is the last one, and hopefully, we're going to make it into a really, really good one. Okay, and we're going to be covering bonding. So far, we've covered atoms, we've looked at elements, we've looked at ionic bonding, we've looked at building blocks in biology as well. So we looked at cells, and today we're going to finish it all off, round it all off with metallic and covalent bonding. Okay, but before that, I'm going to be speaking to you guys about joining our Study Masterminds group, which is a free group which empowers parents to support their child's well-being and learning in maths, English, and science. But I'm going to be talking to you more about that towards the end of the session. But let's go on to what we're actually going to be learning today. Okay, so today what we're going to be doing is we're going to be remembering why atoms like to bond. Okay, understand metallic bonding and explain how metallic lattices how a metallic lattice is formed and structured. Know how covalent bonds are formed. um, Draw dot and cross diagrams, and then we're going to recap all of bonding. Okay, so we're going to recap ionic, metallic, and covalent bonding today. So remember, I always say to you, what's the point in learning all of this? Why do we need to learn it? Okay, last sort of week when we looked at, or the week before when we looked at ionic bonding, I said, hey, who likes chips? Because by now you should know I love chips, okay? And I love it with lots of salt and vinegar on it. I'm a sucker for chips with salt and vinegar, okay? Now, salt, um, NaCl, so sodium chloride, is an ionic compound, and we learnt all about that. Vinegar, on the other hand, is a covalent compound. I'm going to learn about covalent compounds today. And then sodium, so the metal, okay, if it's just sodium by itself, which makes up sodium chloride, the salt, has metallic bonding. Okay, so guys, we use things all around us every single day that has these types of bonds in them. So I think it's really important that we understand how they work and why they do the things they do. So let's begin with this. Why do atoms like to bond? Hey Claire, Nice to have you here. So tell me, why do atoms like to bond? Well, remember, okay, these over here, these are known as the noble gases, okay? And the noble gases have full outer shells, okay? So if they have full outer shells, what do we say they are? Pop it in the comments. I want to see. So if they've got a full outer shell of electrons, what does that make them? Just waiting for some comments. Over here. Yep. Okay, great. So I mean, for full outer shells then, we know for noble gases, that means that they are stable. Okay, so noble gases, all other atoms are really jealous of the noble gas atoms, and that's because they have a full outer shell. That means they're more stable, which means they are unreactive. Okay, and if they're unreactive, that means the word for that is inert. That means that they do not react. Now, all the other atoms will lose, gain, or share electrons just to become like a noble gas. So it has a full outer shell of electrons. So I would like you to put the title on your page, Metallic Bonding, okay? And I just want you guys to refamiliarize yourself with the periodic table again. Remember, we've got groups. Okay, groups are the ones like so. These are the columns going downwards. So you got group 1 there, you got group 2 there, 3, 4, group 5, 6, 7, and some people call that group 8, or you can call that group 0. Okay, so you've got these different groups and you've got the periods across. Okay, so that's period 1, period 2, period 3, 4, 5, 6, and 7. So if we look at metals, right? Metals can be found, remember, in group 1, group 2, okay? You've got these in the middle. They're known as D block elements. Okay, some of you will know them as transition metals. And then you have, you know, all of these over here as well, which are metals. Okay, so remember, you've got your metallic bonding, you've got your groups 1, 2, some of group 3, etc. in there. So just want you just to remember where we find these actual metals itself. Now, what you got to remember is that metals always lose electrons. That's a key point for you to write down. Metals always lose electrons. Remember, what we did last week was we looked at, oh, sorry, the week before, we looked at ionic bonding, okay? And if I've got, say, lithium over here, okay, lithium has got the atomic number 3, which means it's got 3 electrons. So if I was to draw lithium as just the atom, okay, it would have 2 electrons in the first shell, and in the second shell, remember our rules, our filling rules, it would have 1 electron. So it's got an electronic configuration of 2, 1. Okay. Now remember, lithium wants to become just like a noble gas, or any metal for that matter. It wants to be just like a noble gas. So it has 2 options. Either it can gain 7 electrons, okay, to get a full outer shell, because remember in the second shell we can have a maximum of 8, or it can lose 1 electron. Now for a metal, what's going to be easier? It's going to be super easier for it to lose that 1 electron. Okay, so what will happen then is that lithium will just have those 2 electrons. Okay, we get rid of that second shell with that 1 electron, we put a square bracket around it to say, hey, it's lost an electron or it's lost electrons. And then we put a charge on, okay? We put the charge on to say, okay, it's lost one electron, so I put just a positive charge, okay? And normally we would represent this as saying lithium goes to lithium plus an electron. So we're saying that lithium atom has now turned it into a lithium ion plus an electron. Okay, so that's basically what's happening here. It's easier for metals to lose electrons. Okay, right. So this is just basically what we were talking about previously about metals and how they like to lose electrons. So we gave that example of lithium. So I'm just going to write that down there. Okay, and we're going to show what actually happens. So once we've got these lithium ions, yeah, so imagine I've got this lithium ion. So we've shown how it becomes the ion, and I'm just going to just draw this down as a round blob as the lithium ion. Next to it, right, what will happen is, you know, that electron we lost, that's going to be hanging around kind of next to it, not too close to it, but it's going to be hanging around next to it. And what's going to happen is we're going to have another lithium atom turn into a lithium ion because it wants to be stable. So when it does that, okay, another lithium ion is formed and that electron is just hanging around like so. And then if you imagine I've got another lithium, same thing's going to happen here. Okay. So imagine over here I've got like a block of lithium, for example, which is, like I said, it's a metal. Okay. What will happen is inside that block, you'll have all of these lithium ions that will be hanging out next to these electrons. Now, these electrons that have been lost from the original lithium atom, okay, are known as, and I'm going to put, this is a key word, delocalized electrons. Okay, so these are known as delocalized electrons. Now, delocalized just means that these electrons aren't fixed in place, okay? So that's a key word. I'm going to put it over here so you can see it properly. Delocalized electrons. And by the way, I use shorthand with E with a negative charge on top over here. So when I'm writing notes, it's just a quick way for me to write electrons. So what we've got here is we've got these positive ions which are surrounded by these delocalized electrons. Okay, so I just want you to tell me one thing. Okay, imagine if I've got lithium ions, they're all positively charged next to each other. Will they stick to each other? Will they form a tight lattice? What do you think? Will they form a tight lattice? If I've got two things that are positively charged next to each other, what are they likely to do? Yeah, yeah. So what will happen over here is that if I've got two positively charged ions that are close together, they will end up repelling. So you've got to think of these delocalized electrons like super glue, okay? Because they're negatively charged here, there's going to be these forces of attraction between the delocalized electron and the positive ion. Okay, and there's going to be some attraction there. There's going to be attraction between there, between that delocalized electron and that positive ion, like so. etc. And what these delocalized electrons do is they pull these ions closer together like superglue. And what will end up forming is something that looks like this. Okay, so it's brought those things, those ions, closer together. Okay, so the best thing for you to write down is that, you know, delocalized electrons, write this point down. Delocalized electrons hold positive metal ions together like superglue. That's what you've got to imagine it to be. It's like an adhesive. Okay, because of the negative charge attracting to the positive charge, it brings them closer together. And the lithium plus ions, normally what they would do is they would repel, because you'd be like, oh gosh, got positive charge, two positive charges. That means, therefore, they would normally repel. Okay, so delocalized electrons hold positive metal ions together like super glue. So effectively in an exam, what you'd be asked to sort of draw metallic bonding, or you'd be to draw a metallic lattice. Okay, and essentially they will also ask you to describe the bonding in a metallic lattice. And the key definition is here. Okay, and this is what I want you to totally write down. If you were to describe metallic bonding, okay, metallic bonding is when metal ions are held together by a sea of delocalized electrons. Okay, do you see you've got all the delocalized electrons? They were formed when the atom formed the ion. Okay, so we lost those electrons. They're hanging out close by, pulling all the positive ions closer together, acting like superglue. Okay, and then what happens is that eventually, when there's lots of these positive ions, which are surrounded by a sea of delocalized electrons, when they are together, they form these giant metallic lattices. Okay, excellent. Okay, so that's what they end up forming. So this slide, the points over here are super important for you to remember. And guys, a lattice just means structure. It's just another word for structure. Okay, so all metals have metallic bonding and they form giant metallic lattices. Okie dokes. So metallic bonding actually is super easy. Okay, it's just knowing, remembering that they form atoms, form positive ions, lose electrons. Those electrons are known as delocalized electrons within a metal, and then they pull positive metal ions together. Now, let's talk about metallic lattices then. And remember, a lattice is just a posh name for structure. Okay, and what you need to remember are the properties of these metallic lattices. Okay, and the first property that you must remember is the fact that it has a high melting point and boiling point. Okay, so what we're saying for the melting point is that if I've got a solid metal, okay, I need to put a lot of energy into it to turn it from a solid and to turn it from a solid to a liquid. If I've got a liquid metal, okay, I have to heat it loads to turn it from a liquid to a gas. Okay, so I've got to put a lot of energy into that. And the reason for that generally is that if you've got, say, a metal with a higher metallic charge, all right, let's explain this for a second. If I've got, say, lithium, you knew that lithium was a positive ion, yeah, and it lost only one electron. If I was to compare the strength of the metallic bond with, say, um, aluminium 3 plus, for example, we know aluminium's in group 3, so it will lose 3 electrons. That means that aluminium 3 plus has got 3 delocalized electrons per ion. Okay, that means it's got 3 times as much superglue to hold it together compared to lithium, which only has 1. So the higher the metallic charge, okay, so the higher the metallic charge, the higher the amount of delocalized electrons and therefore the attraction. So aluminium is a lot more stronger in its metallic bond than lithium. So the next one then, second property is the fact that metals we know conduct electricity. Okay, so the reason for that again is to do with the delocalized electrons. Delocalized means that they're able to move. Okay, and if they're able to move, they're free to carry an electrical charge. So that's super important for you to remember. Metals conduct electricity because they contain these delocalized electrons, these moving electrons, um, and they're free to carry the electrical charge. And the third property that you need to remember about metals is the fact that they're malleable and ductile. And that's because there's no direct bonds between metal ions. So they can slide over each other. So if I look back, if I go back a slide, look, I've got layers. Okay. And these layers are able to sort of slide over each other. And that's why we say that they're malleable and ductile. Okies. Right. So that's what we've covered so far then for metallic bonding. And really, you've got to just remember this, that a lot of it is to do with the fact that they have these delocalized electrons and the different charges on the ions. Now we're going to move on to covalent bonding. But before that, I just want to give you guys an opportunity to write down in the comments if there are any questions. Okay, so I'm just going to write down, do you have any questions about metallic bonding before I move on? So feel free to pop it in the chat, guys. I'd love to hear from you. Okay, brilliant, Claire. Thank you. No, all good. Oh, good. Excellent. Okie doke. So now what we're going to do is we're going to look at covalent bonding. Okay, and this is fun because today I'm going to be making you guys draw lots of sort of diagrams. Okay, so we're going to do lots of worked examples today. So in a nutshell, right, we've done ionic bonding. Remember, ionic bonding was the bonding between metals and non-metals. Metallic bonding is just the bonding of a metal itself. Okay, and covalent bonding is the bonding between a non-metal and a non-metal. Okay, so that's what a covalent bond actually is. And when we look at covalent bonds, guys, and covalent bonding, all we care about, we don't need to draw all the electron shells like we had to for ionic bonding. Instead, all we care about is how many electrons are there in its outer shell. Because we look at that information to find out, okay, how many more electrons does that atom need? And are they able to share them? Okay. So essentially, covalent bonding is the bonding between two nonmetals, and it's all about sharing. Okay, sharing is caring in this case. So let's actually go through what we mean by that. So let's look at hydrogen. So it could be between atoms of the same two of the same atoms. Okay, so here we're sharing our electrons, and we're going to go through some worked examples here. Here, imagine I've got hydrogen. for example. Okay. Hydrogen, the bonding, well, we know is H2. Okay, so it's two hydrogen atoms together. Now let's draw hydrogens separately first. Okay. Now I'd really love for you guys to draw these out as well on your piece of paper. Okay. So imagine here I've got hydrogen. Now hydrogen is in group 1. Okay, if you look on the periodic table, so I'm just going to have to go back a little bit. So hydrogen over here is in group 1. If it's in group 1, that tells you that it has one electron in its outer shell. Okay, so remember the groups tell you how many electrons there are in the outer shell. And I want to test you on this, okay? And make sure that you understand this before I move on. Moving back a slide, I want you to tell me how many electrons are there in the outer shell of nitrogen. Nitrogen, it's a non-metal. Can you tell me in the chat, please, how many electrons are in the outer shell of nitrogen? Pop it into the chat, guys. Excellent, brilliant. Yep, 5, okay? And that's because nitrogen is in group 5, so therefore it has 5 electrons in its outer shell. And we call those electrons, we call them a special name, okay? So outer shell electrons, the number of electrons in its outer shell is known as valence electrons. So that's another key term. So let's write that down. Valence electrons basically is a posh chemistry word for saying um, the number of electrons in the outer shell. Okay, so hydrogen is in group 1, and I know it's in the same group as say metals, but we know that hydrogen is a non-metal. Okay, so what I do is I will first draw the valence electrons, how many I've got in my outer shell. So in one of the hydrogens, I've got 1. I'm going to draw another hydrogen over here because hydrogen is a diatomic molecule. That means that I have two hydrogens like to bond together. And again, because hydrogen has got 1 electron in its outer shell, I'm going to draw another hydrogen atom with a dot. Okay, so we're going to draw these dot and cross diagrams to show the bonding in hydrogen. Now look, at the moment, the valence electrons, okay, we've got is 1 in each. Okay, now to get a full outer shell, remember it's only got the first shell. So in the first shell, we need 2. Okay, so for the full outer shell, you need 2. Okay, so how many does that hydrogen need to fulfill that because it's the first shell? Well, hydrogen needs 1 electron, doesn't it? Each. Now, because it's bonding between both, that hydrogen, the first hydrogen, can't just give away its electron to that hydrogen there. That doesn't work. So what will happen is it will end up forming a covalent bond like so. So I've got 1 hydrogen here, 1 hydrogen there, and I draw them as overlapping because what happens is the cross from this hydrogen and the dot from this hydrogen is shared between both hydrogens. Now, look at this first hydrogen here. That first hydrogen over here has 2 electrons, and so does this hydrogen over here. This hydrogen over here also has 2 electrons. So this is a covalent bond, okay? When we've got a dot and a cross next to each other, we have something known as a single covalent bond. And the way we represent that, so we would draw the dot and cross diagram like this, but the way we would represent it in terms of bonds would be H, H like so. That represents a single, that line there, a single covalent bond, which just means I'm sharing a dot and a cross like so. Okay. So super easy, guys. We just got to be mindful of which groups our electrons are in and how many more they need. Now, chlorine is in group 7. Okay, chlorine again is a non-metal, but this is a diatomic molecule, just like hydrogen. Okay, that's why hydrogen is represented as H2. We call it diatomic. Okay, so if we look at chlorine now, this is just the bonding between two chlorine atoms. So if it's in group 7, we say that the valence electrons are also 7. Okay, valence meaning outermost, and that's what we care about. We don't need to draw all, or there's my clock going again. We don't need to draw all all of the shells. So if I've got chlorine, I'm going to draw one chlorine like this. I'm just going to draw the outer shells because that's all I'm interested in. I'm going to draw 7. So remember, 1, 2, oops, let's do it this way first. You do them individually. 1, 2, 3, 4, 5, 6, 7. Okay, and then you pair them up. I'm going to then draw another chlorine, like so, over here. And this time I'm going to represent that other one with dots. Okay, so I'm going to do 1, 2, 3, 4, 5, 6, and 7, like so. Now, it's got 7 electrons in its outer shell, right? So we know that to get a full outer shell, that chlorine will need 1 electron, okay? It will need 1 electron each. Now, obviously, remember this isn't ionic bonding, so we can't donate and we can't accept electrons. It doesn't work like that. We've got to share. So the way that we share over here will be to draw them entwined like so, okay? And you've got 1 chlorine. So I'm going to draw those as crosses. And the reason why I do that is just so that it just differentiates where I'm getting my electrons from here. And then the other chlorines, electrons, I'm going to pop them here, okay? Now, look here. I have got a dot and a cross. That means that this chlorine over here has now been fulfilled. It's got 8 electrons in its outer shell. Whoopee, okay? And this chlorine, same thing here. It's got 8 electrons in its outer shell. So we've got the dot and the cross, which means now I formed a single covalent bond. And that's why Cl bonded to another Cl is Cl2. We've got a single covalent bond because I'm sharing 1 dot and 1 cross. Okay, so again, chlorine is known as a diatomic molecule, okay, because it likes to hang out by itself. Hydrogen is one of them. Bromine is one of them, Br2. Iodine is another one as well, I2. They like to hang out in pairs. And actually, oxygen is one as well, O2. But we're going to find out whether or not it contains single or double covalent bonds. Now, the next one is methane. So the worked examples that I'm going through with you guys are the ones that the examination boards would want you to be able to draw very quickly, okay? So I want you to tell me in the chat, what do you know the formula? What's the formula for methane, the chemical formula? Pop it into the chat for me. Tell me, what's the formula of methane? I'd love to know. If you're not sure, don't worry. Let me know. Yeah, I'll give you a clue. it's got carbon and it's got hydrogen in it. Okay. And we would say it's got one carbon and it's got four hydrogens in it. So it's CH4. Well done, Claire. Brilliant. Okay. Excellent. So CH4 is the formula of methane. So now what we've got to do is we've got to think, right, if I've got carbon, and I know this formula kind of tells you how you need to draw it, but imagine over here I've just got carbon, all right? Now carbon is in group 4. So it's got 4 valence electrons, okay? So I want to draw it as 1, 2, 3, 4. And I'm going to draw over here a hydrogen. And remember, hydrogen is in group 1, so it's got 1 valence electrons. So think about what one of the carbons will need. Carbon has got 4 valence electrons, and in order for it to get a full outer shell, it needs another 4, doesn't it? Okay. Now, hydrogen needs 1, okay? So, and it can give 1 to one of the carbons. So what that means is one of the hydrogens can form a covalent bond with the carbon, like so. Then I could get another hydrogen, and another hydrogen, like so. So what we'd end up forming is something that looks like this. Okay, so I've got there, like so, a dot and a cross, like so. Okay, so what's actually happening is we've got 4 lots of separate dot and crosses. Okay, so what that looks like is this, CH4. We've got 4 single covalent bonds. Okay, so this is an example of a compound containing carbon and hydrogen. And do you know what the name of these types of compounds are called? A compound containing carbon and hydrogen only. Pop it into the chat. What is that, guys? Excellent, Claire. I like what you put there. It needs 4, you're right. So a compound containing, I'm going to write that in the chat. A compound containing carbon and hydrogen only is called, I'd like you to think about that. Okay, I'm going to move on to the next bit. I'm going to check back on the chat to see if you've been able to answer that for me. And that definition that I put down, a compound containing carbon and hydrogen only, okay, that is the examination definition. That's what the examiners want. And that part only, okay, is really important for you to write, especially for A level as well. If you just said it's a compound containing carbon and hydrogen, well, that won't get you the mark, okay, because you've got to say it only contains carbon and hydrogen. And well done, Claire, you're on top form. Yep, it's hydrogen, hydrocarbon. Excellent, well done. Okay, now the next one that we're going to look at is water. Okay, so we have water, which we all know is H2O. Okay, now just so you remember, hydrogen is in group 1, so we know that it has 1 valence electron, and oxygen is in group 6, so it has 6 valence electrons. Okay, so if oxygen is in group 6, how many does it need? Okay, well, it would need 2 electrons, and hydrogen again would just need 1. So the best thing for you to do is draw the oxygen first. Okay, and if I draw oxygen, again we only care about the valence electrons, so we do 1, 2, 3, 4, 5, and 6. And notice with oxygen, I've got two paired electrons. These are known as paired electrons over here. Okay, so these are your paired electrons. That means that, let me just put that there. Paired electrons means that they don't need to have any dots next to them because they're already paired. They're already hanging out as pairs. So really, the two electrons need to be here and here. Okay, so we need to get one electron there and one electron there. Well, that's great news because one hydrogen has one, each hydrogen has got one electron, hasn't it? Okay, so what we can end up forming is this. So I've got my oxygen. So I'm just going to draw it like this for now. So here's my paired electrons, and these are my single electrons, like so. That's my hydrogen. That's my dot, cross. That's my dot and cross there from another hydrogen. Okay. So with water, I've got an oxygen, which is has a single covalent bond with hydrogen, and also has another single covalent bond with another hydrogen. But what we like to do as well with water is show that it also has these things called lone pairs on them. Okay, so we say, oh, it's got those two lone pairs there as well. So if you wanted to be a bit more sophisticated with the way that you draw it, yeah, do that. And especially if you're serious about doing science at a later stage as well, it's good for you to know this sort of thing. Okie dokes. Right, now we're going to go for carbon dioxide, okay? So if we look at carbon dioxide, carbon then, okay, let's look at which group carbon is in. So I'm just going to go back over here. Right, carbon is in group 4, okay? And oxygen we know is in group 6. So what I must do is always remember, guys, the reason why I did that was to always refer back to your periodic table. You are not expected to remember the periodic table or to rehearse it by heart. You don't need to do that. Always refer back to the table as much as you can. So carbon, you said, is in group 4, so it's got 4 valence electrons, okay? And oxygen, we know, is in group 6, so it's got 6 valence electrons. So let's think about how many electrons carbon will need. Well, if it's already got 4 valence, it needs 4 more. Okay, and oxygen will need 2 more. All right, so that's interesting. Okay, this is a little bit different. So sometimes the good starting point, I would say, is just draw your electrons in. 1, 2, 3, 4. And then you'll start to be able to see a bit of a pattern. Then draw your oxygen. Okay, so I'm going to draw 1, 2, 3, 4, 5, 6. So these are my two paired, and these are my separate ones. So you've got to think, this oxygen needs 2. Let me look at carbon. Well, actually, carbon has got 1, 2 there. So that means that these two can join a dot and cross from the carbon, can can have a dot and cross with that oxygen. And likewise, if I had another oxygen over here that I draw 1, 2, 3, 4, 5, 6, you'll get one that joins with that and the other one that is shared with that one, like so. So what we'll end up getting is something that looks like this. That's my carbon, oxygen. Okay, so here I'll have a dot and a cross, another dot and a cross being shared, and those will be your normal paired electrons, like so. And I'm going to do another oxygen here. Okay, so that's my dot and cross, like so. And you'll have 1, 2, 3, 4. Okay, like so there. And now this is your carbon dioxide. All right. Now remember, one dot and cross is a single covalent bond. If I've got two dots and crosses together, that's known as a double covalent bond. Okay, so you've got your single and you've got your double. So what this would look like is this: C double bond O, C double bond O, like so. So that's your double bond is your double covalent bond. Wonderful. Now let's look at oxygen. Okay. Now again, oxygen, like we mentioned before, oxygen is a diatomic molecule. So if I've got oxygen, remember oxygen is in group 6, so it's got 6 valence. Okay. What does it need? It needs 2 electrons. Okay. So if I was to draw one of my oxygens, now this should be super easy for you. If I was to draw one of my oxygens like so, remember it's got 1, 2, 3, 4, 5, 6. Okay, so I've got 2 electrons over here that are single, okay, and that could be paired up. Now if I was to draw another oxygen, and I'm going to draw it 1, 2, 3, 4, 5, 6, this electron from that oxygen can pair up with the electron from the other oxygen like so, and what will end up forming is this. My circles are getting really bad. I need to sort them out. So I've got here, those are your paired ones. Another set of paired electrons over here, and I've got my dot, my cross, my dot, and my cross, like so. Okay, so again, because I'm sharing, because I've got 2 dots and crosses in this sharing area, what I'll end up getting is O double bond O. Again, that's a double covalent bond. Okay, and because it's O double bond O, we say it's O2. Okay, it's diatomic. Right, the next one is ammonia. Okay, now the formula for ammonia, it contains, well, I'm not going to tell you the formula yet. The ammonia contains nitrogen and it contains hydrogen. Okay. Now, nitrogen is in group 5, so therefore it's got 5 valence, and hydrogen has 1 valence. Okay. So let's look at nitrogen over here. Nitrogen would need nitrogen would need 3, okay, and hydrogen also needs 1 electron, okay. So if you prefer, draw it out. Let's draw out the nitrogen first and sort of envision what's going on here. So we've got 1, 2, 3, 4, and then we pair up 5, okay. And then I've got a hydrogen, and that's my dot like so. And one of the hydrogen's dots can link together with one of the nitrogens there. Notice here where I've got 2 crosses, that means they've paired electrons, so they're not going to engage in any bonding. Okay, so that's great. We've managed to actually get, 1 electron from the hydrogen. And again, we can get another hydrogen over here. Okay, and it can form a bond with that X there. I've got another hydrogen here and I can form another bond with that X there. So essentially what I could get is a dot and cross diagram that looks like this. So those are my paired electrons. Got a dot and a cross here with a hydrogen, dot and a cross here with another hydrogen, and I've got a dot and a cross here with another hydrogen. And so what we'll end up getting is NH3. And again, I'm just going to draw my two lone pairs on top of the nitrogen like so. So again, they're just single bonds, guys. Yeah, single covalent bonds, and that has your lone pair over there. Okay, so the formula for ammonia is NH3, and it contains single covalent bonds. Right, okay, so this is basically your chance to ask me as many questions as you want. Good. Oh, I can see some more comments now. Sorry. Hi, Caroline. No worries. Just keep going. Just keep watching the video. Love for you just to have a go at it. Well done, Claire and H3. You've been doing really well. I've noticed you've been doing extremely well in these sessions. So well done. Now is your chance to ask me questions about bonding. Okay, so we've got some time to go through some bonding review questions. So I'm just going to sort of start you off in terms of your thinking. So far what we've done over our sessions is we've looked at ionic bonding. Okay, we've looked at metallic bonding, and we've looked at covalent bonding. Okay, so what information do we have? What can you tell me about ionic bonding? What can you tell me about that? Give me some facts. Let's get some facts put into the chat box. Start you off. Okay, so for ionic bonding, remember it's the bonding between a metal, okay, and non-metal. Okay, so that essentially is what it is. Ionic bonding is the bonding between a metal and a non-metal. A metallic bonding is just the bonding in metals itself, and covalent bonds is between a non-metal and a non-metal. Okay, so that's what a key facts that you need to remember there. Okay, now for ionic bonding, metals will always excellent. Well done, Claire. Yeah, ionic bonding is with metals, and remember to say metals and non-metals. Yep, good. Okay. Now, ionic bonding, again, remember metals, they form positive ions, and non-metals form negative ions. Um, the name for a positive ion is known as a cation. Okay, and negative ions are known as anions. Okay, and when they attract together, the forces of attraction in the structure are called electrostatic forces. Forces of attraction. Okay, now remember, metallic bonding is the bonding within the metals itself. Okay, so let's write that down, within the metals. And it's quite simply, it's when you've got metal ions surrounded by a sea of delocalized electrons. Okay, so that's what they are there. And covalent bonds is where you've got the sharing of those electrons. Okay, so this is basically just a general overview of your ionic, metallic, and your covalent bonds. Okay, brilliant. Okie dokies. So what we're now going to do is review our learning, and also I just wanted to invite you guys to something that we're starting actually. So just stick with me, and I'll speak to you about that in a second. Firstly, let's review our learning. Remember why atoms like to bond. So remember, atoms want a noble gas configuration, which makes them stable and therefore inert, which means that they're unreactive. Um, One of the other learning points was to understand why understand metallic bonding and explain how a metallic lattice is formed and structured. So again, you just got to remember this. Positive metal ions are surrounded by a sea of delocalized electrons. Okay, so that's all we're saying. And remember, guys, if you've got, say, sodium plus, because remember sodium and aluminium, say if they wanted to compare the strength of the metallic bond in sodium and aluminium. Remember, sodium is in group 1, so it's going to form sodium plus ions. Aluminium is in group 3, so it's going to form, whoops, aluminium is going to form aluminium 3 plus ions. So remember, it's sodium plus will only have one delocalized electron. Aluminium 3 plus will have three delocalized electrons. So not only is the charge increased, but it's going to have three times more delocalized electrons, which makes it stronger. Okay, you've got three times more glue, so to speak. So you need to be able to compare the strength of the metallic bond according to the type of metal you have. The next one is that you need to know how covalent bonds are actually formed. And they're formed when electrons are basically shared between atoms. Okay, so that's when you've got this overlap and you've got a dot and a cross, or in some cases, you might have two dots and crosses. And again, draw dot and cross diagrams. Guys, this just requires lots and lots of practice. I'd suggest having a go at the worked examples that I've done on the video and having a go at them yourself again. Okay, so just trying to do them and practice them and try and understand why those dots and crosses are occurring in the first place. So remember how many valence electrons there are first, and then figure out how many do they need. Okay, so what's the valence? How many do they need? Now, that's all of our learning for today. I wanted to sort of share, like I always do, share some spark wisdom with you guys. This is Oprah Winfrey. Okay, she's super famous, and she's very, very inspirational. Actually, she's got her own show. She's an activist as well, and she does loads of different things. But she says anything you can imagine, you can create, and I really want you guys to focus in on that. This is our last session today. So I want you to remember this, that, whatever you put your mind to, and if you have that intention, if you put that intention out there that this is what you want, this is what you want to achieve, okay, and you know, you can create that through the power of visualization, through the power of faith, and through the power of belief. And you got to believe in yourself. Okay. And I know this whole COVID situation, us being at home during lockdown, guys are trying to manage your learning. You're doing so well. You got to remember you're doing so well, but don't let your dreams be shattered as a result. Don't get freaked out. You can get through this, and I know that. Okay? You just got to keep your mind clear. You got to keep your mind focused, and you've got to remember that what your dreams are, what your goals are. Okay? And I just wanted to say a big thank you for being part of the journey. Doing the lockdown lessons have been great. Unfortunately, not unfortunately, we've got a lot of things going on at the center at the moment, which means that I have to crack on with those things. But I've actually really really loved having this time with you guys. In fact, what we're doing is I'm spending a lot more time with my year 11s who are transitioning into A-level chemistry, and also we're coming up with loads of cool programs for our students to do over the summer holidays. But what I'd like you guys to do is this is absolutely free. I'd love for you to join our Study Masterminds group. Now, this is a group that I'm going to be launching this week, but I've got the page up and running. So it's a private group, and the aim of this is to empower parents to support their child's well-being and learning in maths, English, and science. So the idea is that we exchange ideas, we talk about ways in which we can get your kids motivated. If there's other parents in the group, share tactics and tips that they've done to help inspire their children. And we'll be sharing all of our knowledge and all of our skills in this area as well. Things that we do to try and engage our students. If there's things that you're struggling with as well, oh gosh, there's my clock again. If there's things that you're struggling on, any homework questions or anything like that, my team will be willing to help and support you guys as well. So this is the Study Masterminds group is just a way for us to help as many parents as possible, as many students as possible, because that actually is my vision. My vision is to make sure that we help as many children and as many students as possible during our time, and that's what I want to do. So it's absolutely free. I'd love for you guys to join. Let's exchange ideas. Let's help. Let's create a community that really wants to feel empowered and help their children as much as possible. So I'd love for you guys to join. So if you just type in Study Masterminds, that would be great on Facebook. Or if you're struggling to find it, DM me and I can send you a personal invite as well. So let's do that. But it's Study Masterminds powered by Spark Academy. And finally, remember that our live video and lesson resources will be made available on our website on the Lockdown Lessons tab. And you'll also get access to our resource for covalent and metallic bonding as well. We've also put on there bonus video materials. So you've got primary maths video materials, and you've also got secondary school maths materials as well. We've also launched our own maths course as well, GCSE, a secondary school maths course, which is a structured course designed to help you get through secondary school maths. So whether you're studying Key Stage 3 or whether you're doing GCSE maths, we've got a structured maths course which has loads of videos, it has loads of notes, it has structured worksheets, and it has the answers on them as well, and lots of exam guidance on there. So if you're up for that, if that's something that you would like to sort of look into, then please again feel free to DM us, and I'm here to help as much as possible. So it's been a wonderful experience, guys. Claire, thank you. It says thank you so much. I've really enjoyed these sessions. Oh, thank you so much, Claire. It's been great. And look, like I said, keep in touch. I'd love for you to join our group. Let's start a little community. It'd be wonderful. Randip, oh, thank you, Randip. Actually, Randip is a very good friend of mine from back in our PGC days. She's doing absolutely wonderful things. Thank you, Randip. Kirsten, thank you. We've really enjoyed the sessions. Well, that's really great. Thank you so much, Kirsten. And like I said, this doesn't need to stop here. This doesn't need to end here. I'd love for you to join our group. Okay, I'd love for you to be part of our Facebook group. And it's just a way for us to exchange information, build a community, empower as many parents as possible to help their children, especially during the homeschooling time and also moving forward as well. So it's been an absolute pleasure. Um, and what I'll do is later on, I'll probably post the link in this chat box for you to join. And like I said, I don't want this relationship to end. I think we can work together some more. So brilliant. Thank you very much, guys. Super pleasure. Okay, and all the best. Feel free to ask me any questions, DM us, join the group. Peace out. Thanks, guys.